Welcome to this in-depth exploration of wind energy. As one of the most promising renewable energy sources, wind power has captured the imagination of engineers, environmentalists, and policymakers alike. However, beyond the towering turbines and their clean energy potential lies a range of challenges that deserve our attention. In this discussion, we'll dive into the complexities of wind energy, focusing on the negatives that often go unnoticed in its pursuit as a sustainable energy solution. By the end, you'll have a clearer understanding of both the promises and the pitfalls of this remarkable technology. Let's begin. The complexities of wind energy. Wind energy is often celebrated as one of the cleanest and most sustainable sources of power available. Harnessing the natural movement of air to generate electricity, it offers a renewable alternative to fossil fuels, promising a future of reduced greenhouse gas emissions and energy independence. However, like any technology, wind energy is not without its challenges. While the advantages of wind energy are clear, the drawbacks are equally significant and merit careful consideration. Factors such as intermittency, high initial costs, environmental impacts, and social resistance have sparked debates about its viability as a long-term solution. Understanding these complexities is essential to fully evaluate the role of wind energy in the global transition to renewable power. This exploration delves into the negatives of wind energy, shedding light on the obstacles that hinder its adoption and effectiveness. By addressing these challenges head-on, we can pave the way for innovative solutions that enhance the potential of wind energy while minimizing its drawbacks. Let's uncover the intricacies of this promising yet imperfect energy source. The problem with wind energy. This is a map of the world's wind resources, and with this, we can see why the Midlands of America have the highest concentrations of wind turbines in the country. More wind means more energy, yet a small island off the European continent reaches its maximum average wind speed. The load is a wind energy paradise in a single major storm. The wind grid comes with many logistical problems that are made more difficult for a small, isolated island, from energy storage to high-frequency stability. When energy is a difficult resource to build a stable grid, to understand why we need to take these engineering marvels to see how they work hidden inside the turbine. The s.a.r.l is an engineering marvel. We cannot generate useful electricity with the low and high torque rotation of these huge turbine rotors. They spin about 10 to 20 times the minutes it takes for a generator to spin about 1,800 times per minute for the blades to convert the extremely high torque into more revolutions. Fast, this step increases the rotational speed of 4 planetary gears used for upshifting or downshifting because they have more contact points to share the load between the gear teeth sink deeper into the gearbox without extensive maintenance. This is not a problem specific to gearboxes. In wind turbines, however, changing the gearbox in your car is not the same as a team climbing 50+ meters to replace a multi-million-dollar gearbox. Wind flow costs, salty conditions, and the difficulty of accessing offshore turbines further increase maintenance costs. The cost of maintaining a wind turbine can be as much as 20% of the cost of fixed electricity. But in the grand scheme of things, wind is still incredibly cheap. However, we do not know the exact mechanics of the generator directly, but a different type of generator is required. The generator output frequency must match the frequency of the large, slower alternating magnetic fields that increase the output frequency. The largest wind turbine ever built, the Helion X, uses a direct drive system. You can see the positions of the large diameter generators. Unfortunately, negotiations take years to assess the utility of new energy technologies like this, but as wind turbines get larger and more expensive, direct drive systems become more attractive. The next challenge is electricity created inside these generators to match the great frequency when the speed of the wind constantly changes. The frequency of current created by permanent magnet generators matches the speed of the shaft. If we wanted the generator to output the US standard 60 Hz, we could decide a rotor to rotate 1/800 times per minute. Hydro stations online, because a huge portion of the population, this increased the load of the grid, and without a matching in apply, the frequency would have dropped. The grid is very sensitive to the shifts a small 1 Hz. Change can bring a lot of destruction. During the 2021 freeze in Texas, the grid fell incredibly close to 59 Hz. It was teetering on the edge of a full-sealed blackout that would have lost it for months. Many people solely blamed when turbines. Texas is awesome isolated power grid that has a large percentage of wind energy. The problem with wind energy is that it isn't capable of raising the great frequency. Turbines are non-synchronous, and increasing the percentage of wind energy on the grid requires additional infrastructure to maintain a stable grid. To understand what non-synchronous means, we need to dive into the engineering of wind turbines. Once again, the first electric wind turbines connected to the grid were designed to spin the generator shaft at exactly 1/800 RPM. The prevailing winds dictated the size and shape of the blades. The aim was to have the tips of the blades move at around 7 times the speed of the prevailing wind. The tips of the blades were designed to stall if the wind speed picked up. This let them have a passive controls of wind would increase torque rapidly, which was a recipe for fatigue failures in the drivetrain. So to extract more power juice instead of fixed blades that depended on a stone mechanism for control, the blades were attached to the home with a massive bearings that would allow the blades to change their angle of time. This provided an active method of speed control. But now another problem emerged. You connect a very infrequency generator to the grid. The power has to be passed through to inverters. The first converts the varying AC to DC using a rectifier. This is done with electronic switches that rapidly turn on and off to create the oscillating way. If with electronic switches that rapidly turn on and off to create the oscillating way, we lose some power in this process. But the larger issue for the grid as a whole is that this removes the benefit of the wind turbines inertia. Slowing something heavy rain is difficult because it has a lot of inertia. Power grids have inertia, too huge, rotating steam turbines connected directly to the grid, or like these trains, they can't be slowed down. Increases in demand on the grid and gives great operators more time to bring on new power sources. Wind turbines, of course, have inertia. They are large rotating masses, but those inverters mean their masses aren't connected directly to the grid, and so their inertia can't help stabilize the great solar panels. Suffer from the same problem, but they couldn't add a nursery either way as they don't move. This is an issue for renewables that can become a critical vulnerability when politicians push to increase the percentage to renewables onto a grid without considering the impacts that can have on grid stability. Additional infrastructure is needed to manage this problem, especially as older energy sources that do provide inertia begin to shut down. In 2023, the world's largest flywheel, a 120-ton steel shot that rotates 3,000 times per minute, was installed in the location of a former coal power plant, a location that already had all the great infrastructure needed to connect to the grid. This flywheel takes but 20 minutes with increasing amounts of wind energy. Bush. They aren't designed for long-term energy storage. They are purely designed for great frequency regulation. Ireland's next problem is more difficult to overcome. It's an isolated island with connections connecting to other energy grids, and trading energy is one of the best ways to stabilize a grid. Larger grids are just inherently more stable. In an ideal world, Ireland could sell energy to France when winds are high and buy nuclear energy when they are low. Instead, right now, currently planned with France, with Ireland's average demand 4,000 megawatts, this interconnection can provide 5% of the country's power needs when wind is slow, or sell that way to France when it is fine. This allows Ireland to remove some of that we've done, that sea from its great while, making it worthwhile to invest in more wind power. As the access now has somewhere to go, the final piece of the puzzle is to develop long-term energy storage infrastructure. Ireland now has 1 gigawatt hour of energy storage, but this isn't anywhere close to the amount needed. Ireland's government has plans to develop a hydrogen fuel economy for longer-term storage and energy exports in the National Hydrogen Plan. They have set a course to become the leading producer of green hydrogen in Europe, but for domestic use and for export. With Ireland's abundance of fresh water thanks to its absolutely miserable weather, our prime locations and being the home of the world's third largest airline, Ireland is very well placed to develop a hydrogen economy. These transport routes are not easy. Ireland plans to start the project by generating hydrogen by electrolysis using wind power, which has been shut down due to oversupply. It is essentially free energy as the market matures exclusively for hydrogen production by 2015. Ireland is legally bound by EU law to achieve net zero emissions by 2050, but even without these lofty expectations, it is in Ireland's interests to develop these technologies. Ireland has some of the most expensive electricity prices in Europe due to its reliance on fossil fuel imports, which have been dramatically increased in price by the war in Ukraine, making this transition not an easy one. The world's richest countries have always traded energy commodities, but the nature of the business is changing from physical commodities like barrels of oil to less tangible goods. Asset-like electrons stored in batteries, there's an emerging business of private battery storage units that buy electricity when it's cheap, like when the wind is high, and when it's expensive. This business relies on algorithms that sort through data on weather and energy consumption to optimize when to buy and sell. It's a commodity, and that's just one of many functions in the market. The negatives of wind energy. Challenges in harnessing a renewable resource. Wind energy, celebrated for its sustainability and environmental benefits, is not without its challenges. Despite being a clean and renewable source of power, several factors complicate its widespread adoption and raise questions about its long-term feasibility. In this exploration, we delve into the disadvantages of wind energy, examining the technical, environmental, economic, and social challenges associated with this renewable energy source. Intermittency and reliability. One of the most significant challenges of wind energy is its dependency on weather conditions. Unpredictable output. Wind energy production depends entirely on the availability of wind, which can be inconsistent. Calm periods or fluctuating wind speeds lead to irregular power generation, making it unreliable as a sole energy source. Backup systems required. To ensure a stable energy supply, wind farms often need backup power systems, such as fossil fuel-powered plants or energy storage solutions, which can increase costs and negate environmental benefits. High initial investment costs. Although operational costs are low, the upfront costs of wind energy systems can be prohibitive. Turbine installation. Manufacturing and installing wind turbines require significant investment, particularly for offshore wind farms. Infrastructure costs. Connecting wind farms to existing power grids, especially in remote locations, involves substantial financial and logistical challenges, economic barriers for small communities. For rural or underdeveloped regions, these costs may limit access to wind energy hindering equitable adoption. Environmental and wildlife concerns. While wind energy is environmentally friendly in terms of emissions, it poses unique ecological challenges. Impact on wildlife. Wind turbines are known to harm birds and bats, often leading to fatal collisions. Migratory species are particularly at risk in areas where wind farms intersect with their flight paths. Habitat disruption. The construction of wind farms can disrupt local ecosystems, affecting flora and fauna. Offshore wind farms can also disturb marine life during installation and operation. Noise and visual pollution. The constant hum of turbines and their visual impact on landscapes can lead to opposition from local communities, particularly in scenic or residential areas. Land use and space requirements. Wind farms, especially onshore ones, require vast areas of land for optimal efficiency. Land availability. The need for open spaces can lead to competition with agricultural, residential, or conservation uses. Land inefficiency. Unlike solar panels or other renewable technologies that can be installed on rooftops or integrated into existing infrastructure, wind turbines need dedicated land, which might limit their applicability in densely populated areas. Energy storage. Challenges. Storing wind energy for periods of low wind or high demand remains a technological and economic hurdle. High costs of storage. Advanced battery systems capable of storing large amounts of energy are expensive and have limited lifespans. Inefficiencies. Energy losses occur during storage and retrieval processes, reducing the overall efficiency of wind energy systems. Grid integration issues. The intermittency of wind energy complicates its integration into traditional power grids, which are designed for consistent energy input. Noise and shadow. Flicker wind turbines generate noise and shadow flicker, which can negatively affect nearby residents. Noise pollution. The mechanical sounds from turbines combined with the whooshing noise of spinning blades can be disruptive, especially in quiet rural areas. Shadow flicker. The rotating blades can cast moving shadows on buildings, which some people find disturbing or stressful, particularly during sunrise and sunset. 7. Dependence on specific locations. Wind energy generation is highly dependent on geographic and climatic conditions. Wind availability. Not all regions experience sufficient wind speeds to justify the installation of wind farms. Areas with inconsistent or weak winds may render turbines ineffective or unprofitable. Remote locations. The most favorable sites for wind farms, such as coastal or mountainous regions, are often far from urban centers where energy demand is highest, leading to increased costs for energy transmission. Resource and material demands. The production and maintenance of wind turbines require significant resources and energy. Material intensity. Manufacturing turbines involves the use of steel, concrete, and rare earth metals, which require energy, intensive extraction, and processing. Decommissioning. Waste. The disposal of turbine blades, which are typically made of composite materials, poses environmental challenges due to limited recycling options. Economic and social impacts. While wind energy has economic benefits, it also presents challenges for local communities and industries. Job displacement. Transitioning to wind energy can lead to job losses in traditional energy sectors, such as coal or oil industries, disrupting local economies reliant on these jobs. Community resistance. Opposition to wind farm projects is common, with complaints about visual intrusion, noise, and land use often delaying or halting developments. Scent, maintenance, and longevity. Wind turbines, though durable, are not immune to wear and tear. Maintenance costs. Regular maintenance is required to ensure turbines operate efficiently, especially in harsh climates where they are exposed to extreme weather. Lifespan limitations. Wind turbines typically have a lifespan of 20 to 25 years, after which they require replacement or significant refurbishment, adding to long-term costs. Balancing challenges with opportunities. Despite these challenges, the drawbacks of wind energy are not insurmountable. Technological advancements, better site planning, and policy interventions can address many of these issues. Innovative turbine designs. New turbine technologies aim to reduce noise, increase efficiency, and minimize wildlife impact. Energy storage solutions. Advances in battery technology and alternative storage methods, such as pumped hydro, can mitigate the intermittency of wind energy. Community engagement, involving local communities in planning processes, can help address concerns and build support for wind energy projects. Recycling and sustainability efforts. Research into recycling turbine components and using sustainable materials in their construction is ongoing, aiming to reduce the environmental footprint of wind energy systems. Conclusion: while wind energy presents several disadvantages, these challenges are far outweighed by its potential to drive a sustainable energy future. Acknowledging and addressing the negatives allows us to refine wind energy technology and practices, ensuring it becomes a viable and beneficial solution for global energy needs. By fostering innovation, collaboration, and informed decision-making, wind energy can overcome its limitations and continue to play a pivotal role in the transition to cleaner, greener energy systems. The positives of wind energy. Unlocking the potential of clean power. Introduction. Wind energy is one of the most promising renewable energy sources of the 21st century. Harnessing the natural force of the wind, this clean and sustainable energy solution has gained global recognition for its ability to power homes, businesses, and industries while reducing environmental impact. In this detailed exploration, we will uncover the numerous advantages of wind energy, its transformative role in modern society, and the ways it shapes a sustainable future. One renewable and inexhaustible resource. Wind energy is derived from the natural movement of air masses caused by the uneven heating of the Earth's surface by the sun. Unlike fossil fuels, which are finite and depleting, wind is a renewable resource that will continue to blow as long as the Earth exists. Sustainability. Wind energy is inherently sustainable. It can be harnessed repeatedly without fear of depletion. Availability. Wind exists across the globe, making it accessible to countries regardless of their fossil fuel reserves. Energy independence. By utilizing wind energy, countries can reduce reliance on imported fuels, enhancing their energy security. 2. Environmentally friendly. Wind energy stands out for its minimal environmental impact compared to traditional fossil fuel-based energy production. Zero greenhouse gas emissions. Once operational, wind turbines produce no carbon dioxide, CO2, methane, or other greenhouse gases that contribute to global warming. Reduced air pollution. Wind energy eliminates the release of pollutants like sulfur dioxide and nitrogen oxides, improving air quality. Land conservation. Wind farms can coexist with agricultural land, allowing farmers to use the same land for crop production or grazing while generating electricity. 3. Cost-effectiveness over time. While the initial investment for wind turbines can be high, the long-term economic benefits are compelling. Low operating costs. Wind turbines have relatively low maintenance and operational costs compared to fossil fuel plants. Energy price. Stability. Wind energy is immune to the price volatility of oil, coal, and natural gas, offering a stable and predictable energy cost over time. Job creation. The wind energy industry creates jobs in manufacturing, installation, Maintenance and research, boosting local economies. 4. Versatility and scalability. Wind energy can be harnessed in various settings, making it a versatile solution for diverse energy needs. Onshore wind farms, these are cost-effective and ideal for large-scale energy production in open landscapes. Offshore wind farms, located at sea, these farms benefit from stronger and more consistent winds, significantly increasing energy output. Community and residential wind projects. Smaller-scale turbines can provide energy for rural communities and individual homes, promoting localized energy generation. Energy independence and security. By investing in wind energy, countries can reduce their dependence on imported fuels, improving energy security and fostering resilience against geopolitical uncertainties. Decentralized energy production. Wind farms enable distributed energy generation, reducing vulnerability to centralized power system failures. Long-term planning. With predictable costs and no need for fuel, wind energy allows for more stable energy planning and infrastructure development. Technological advancements. Recent innovations have dramatically improved the efficiency, reliability, and affordability of wind energy systems. Enhanced turbine design. Modern turbines are taller and equipped with advanced blades, capturing more wind and generating more electricity. Energy storage solutions. The development of better battery technologies allows for the storage of surplus wind energy for use during low wind periods. Smart grid integration. Wind energy systems now integrate seamlessly into smart grids, enhancing energy distribution and reliability. Economic growth and community benefits. The wind energy sector significantly contributes to local and national economies. Job opportunities. The construction, operation, and maintenance of wind farms generate thousands of jobs worldwide. Landowner benefits. Farmers and landowners hosting wind turbines receive lease payments, providing them with additional income. Community investment. Wind energy projects often invest in local infrastructure, schools, and healthcare, improving community well-being. Reducing carbon footprint. Transitioning to wind energy is one of the most effective ways to combat climate change. Clean energy transition. Every megawatt-hour of wind energy generated displaces a corresponding amount of energy produced by fossil fuels, reducing CO2 emissions. Alignment with global goals. Wind energy supports international efforts to achieve net zero emissions and adhere to agreements like the Paris Accord. Synergy with other renewables. Wind energy works well in combination with other renewable energy sources, such as solar and hydroelectric power, to create robust hybrid systems. Complementary nature. Solar panels produce energy during the day, while wind turbines can generate power at night when winds are typically stronger. Energy reliability. Hybrid systems ensure a consistent energy supply by mitigating the intermittency of individual renewable sources. Heat, social and environmental awareness. Adopting wind energy reflects a commitment to sustainability and environmental responsibility, inspiring others to follow suit. Corporate responsibility. Businesses investing in wind energy showcase leadership in sustainability, improving their brand image and stakeholder trust. Educational impact. Wind energy projects raise awareness about renewable energy, encouraging communities to adopt greener practices. Challenges addressed and overcome. While wind energy offers numerous benefits, it is not without challenges. However, continued innovation and collaboration are steadily overcoming these obstacles. Intermittency. Advances in energy storage systems, such as lithium-ion and flow batteries, are mitigating the impact of inconsistent wind patterns. Initial costs, financial incentives, subsidies, and declining technology costs are making wind energy more accessible. Wildlife concerns. Improved turbine designs and strategic placement are reducing risks to birds and bats. Conclusion: the future of wind. Wind energy represents a beacon of hope in the fight against climate change and the quest for sustainable energy solutions. Its benefits, including renewability, environmental friendliness, economic growth, and energy independence, make it a cornerstone of the global transition to a cleaner future. As we continue to innovate and address its challenges, wind energy will undoubtedly play an even more significant role in powering our world sustainably. By investing in and supporting wind energy, individuals, businesses, and governments can collectively contribute to a brighter, greener future for generations to come. Call to action: subscribe to the Power Energy channel for more insights into renewable energy solutions. Share this video to inspire others to join the movement toward a sustainable future.